Okay, so hello class, welcome back. So in this recording, we're gonna take a look at the new chapter, which is chapter 9. And then more specifically, we're gonna take a look at section 9.1, estimating a population proportion. Now, this is gonna move on to the second half of semester, which is talking about inferential statistics. Yeah. So the ideas of inferential statistics is we're gonna use some sample statistic, right, to estimate a population parameters. So that's gonna be the ideas of the second half of our class. We're gonna use some sample data or sample statistics to estimate a population parameters. Okay. So the environment of our problem is that we want to estimate the value of some unknown population proportion. So now you want to estimate a population proportion. So most of the time, we usually don't have access to the entire population. That's why most of the time, we usually don't have the answer for the population parameter. So that's why you might need to use in some statistic that we have. And then based on the statistic, we do some further calculations so we can use in the answer to estimate a population parameters. Yeah. So the environment of our problem is that we want to estimate the values of some unknown population proportion. So this is one of the most common goals of our statistic, right? When we analyze the population proportion, the sample proportion is our best guess, right? Or the point estimate. So in order to estimate the population proportion, we're gonna use a sample proportion because that is a proportion from the sample. So hopefully that's gonna be the close value to the population proportion, or that's going to be a good point estimate or the best point estimates of the population proportion. We also want to quantify the accuracies of our calculation process also. So you also want to show how accurate is our calculation. So let's give you the first definition, the point estimate. Okay. So a point estimate is the values of statistic that estimate the values of a parameter. So that's going to be a point estimate. So we're going to use in a statistic to estimate the values of a parameter. So for example, a point estimate for the population proportion will be the sample proportion. Yeah. So the point estimate for the population proportion is the sample proportion. So sample proportion is the statistic. We're going to use in the statistic p hat to estimate the population proportion p. So this is how we calculate the sample proportion. We learned this calculation from the previous section, right? So the sample proportion p has equal x over n, and x gonna be the numbers of individuals in the sample with some certain characteristic, and then n is gonna be the sample size. So we're gonna take x over n to estimate the sample proportion or to calculate the sample proportion, and then from there we can estimate the population proportion. We're going to use a sample proportion as a point estimate of the population proportion. So for example, let's give it a try. So actually, we completed this question in the previous section already, but we're going to try this again then. So in March 2018, a survey asking 1,291 people, registered voter nationwide, if they are concerned about climate change. And then in the group of 1,291 people, 891 say yes, they're very concerned or somewhat concerned about climate change. So among 1,291 people, we find out that 891 say that they're very concerned or somewhat concerned about climate change. So obtain a point estimate. Yeah, so we want to find out a point estimate for the proportion of registered voters who are concerned about climate change. Yeah. So you want to estimate the proportion of registered voters who are concerned about climate change. So this is going to be an estimation of the population proportion. So the point estimates of the population proportion will be the sample proportion. And this is the formula how we calculate the sample proportion. So the sample proportion is equal x over n. Okay. So x is going to be the numbers of people or individual that have some certain characteristic, and then n is going to be the sample size. So based on the question, we have the numbers of people who are concerned about climate change. That's going to be x. So we have X equal 891. And then the sample size, we have 1,291. Okay. And then we're going to use a calculator to approximate this calculation to see what is the proportion of individuals who are concerned about climate change. Yeah. So 891 divided by 1291. Okay. So that's going to be 0.6902. Okay. 0.6902. So about 69% of the population are concerned about climate change. Okay. So we might use in this point estimate, which is the population, the sample proportion to estimate the population proportion. But how accurate is your estimation? So maybe it's not that strong, right? Because you only using one single value to estimate the population, right? So maybe that's not a very good accurate. So that's why we need to do some further calculation to make our estimation become more and more accurate. That's going to be the confidence intervals. Yeah. So what is a confidence interval? So a confidence interval for some unknown parameter consists of an intervals of number based on a point estimate. So based on the sample proportion that we just calculated, we're going to do some further calculation. So we can come up with an intervals of number to estimate the population proportion. That's what I mean by the confidence interval. So a confidence interval is an intervals of number that estimates some population parameter based on the point estimate. Okay, so that's going to be the confidence interval. So for LV confidence interval, we need to know the levels of confidence, right? So for LV confidence interval, we need to know the levels of confidence. So we're gonna use in the CL as a shorthand notation for the levels of confidence or confidence levels. Yeah, CL confidence level. So what's the levels of confidence? Yeah, so the levels of confidence CL represent the expected proportion of interval, the expected proportion of interval that will contain the parameters if a large numbers of different samples are obtained. The levels of confidence is denoted by 1 minus alpha. Yeah, so 1 minus alpha is equal the confidence level. Yeah. So for example, let's give you some numbers so it makes sense with this levels of confidence. So for example, if you have 95% levels of confidence, yeah. So the confidence levels is 95%. So alpha will be equal the complements of that. That's going to be the 5% or 0.05. So if we have 95% confidence level, so which means that if 100 different confidence intervals are constructed, each based on a different sample from the same population, we will expect that 95 of the interval will contain the parameters and 5 not to include the parameter. So that's what I mean by the levels of confidence. So for example, if you have 95% levels of confidence, which means that if 100 confidence intervals are constructed, each based on a different sample from the same population, we will expect that about 95 of the interval will contain the parameter with the 2 parameter, and then 5 not include the parameter. So that's what I mean by the 95% confidence level. Yeah. So that's the definition of the confidence level. Okay, so after we got the ideas of the confidence intervals and levels of confidence, now we are ready to talk about the calculation. What's the idea that we might use it to calculate the confidence intervals? Okay. So let's take a look at this one. The confidence interval for the population proportion are of the form. So we're gonna use in this idea, this formula to estimate the confidence interval to estimate the population proportion. Yeah. So we're gonna use in the point estimate. Yeah. So we're gonna use in the point estimate plus or minus the margin of error. So the point estimate, we got the idea, right? So we got the definition for the point estimate. So the point estimate is the values of a statistic that estimate the values of a parameter. So the point estimate for the population proportion is the sample proportion. So the point estimate should be okay. So if you want to estimate the population proportion, we're gonna use the sample proportion as a point estimate. Now, how we're gonna calculate the margin of error, E? So how we're gonna calculate the margin of error? Yeah. So let's talk about the calculation of the margin of error. How many factors might affect the calculation of the margin of error? Yeah. So the margin of error of a confidence interval estimate of a parameter depend on three factors. Okay. So gonna be depends on three factors. So the calculation for the margin of error will be depends on three factors. What are they? Okay. So the first factor is levels of confidence, right? So because we calculate the confidence level, so it's gonna be depends on the levels of confidence. Yeah. So levels of confidence is the first factor that affect the calculation of the margin of error. Yeah. So the levels of confidence increase, the margin of errors also increase. And then these levels is most commonly, yeah. So the levels of confidence most commonly used is 90%, 95%, or 99%. And then the complements of the 90% will be the 10%. That's how we got alpha is equal 10%. The complements of 95% is the 5%. That's how we got alpha is equal 5%, 0.05. The complements of 99% gonna be 1%, so which is 0.01, which is 1%. So that's the first factor affect the calculation of the margin of error, which is the levels of confidence. Now we're gonna talk about the second factor that affect the calculation of the margin of errors, which is the sample size. So as the sample size of the random samples increase, the margin of errors will be decreased. Okay, so as the sample size increase, the margin of error will be decreased. Now, the third factor that affects the calculation of the confidence levels or the margin of errors is the standard deviation of the population. So the more spread there is in the population, the wider the interval will be for a given confidence level. So when the standard deviation becomes larger and larger or more and more, the confidence interval will become wider and wider for the given confidence level. So those three factors are the one that affect the calculation for the margin of error E. Okay. So after we know the point estimate, after we know the margin of error, now we can put everything together and we are ready to talk about the calculation of the confidence interval to estimate the population proportion. So before we can actually work out on the confidence interval, you have to check the condition, make sure everything good before we can move on and proceed the calculation of the confidence interval to estimate the population proportion. Okay, now suppose that we are creating the confidence intervals about sample proportion of a sample size n from a population of size uppercase N, then we must check the following. So this is going to be the condition that you have to check it first before you can actually perform the calculation or the construction of the confidence interval. So the first requirement is the data obtained must come from a random sample. So the first condition I'm going to say, make sure that the sample that we selected is going to be at random. So make sure that we have a simple random sample SRS. Simple random sample. The second requirement is familiar, right, everyone? Yeah, so n times p hat times y minus p hat is more than or equal to 10. You gotta remember this when we talk about the sampling distribution of the sample proportion, right? So you want to make sure that this condition is true to ensure that the sampling distribution of p hat is approximately normal. Yeah. So this is the second requirement, n times the sample proportion. 1 minus the sample proportion have to be more than or equal to 10. Okay. Now, the third requirement that we want to make sure is the sample size is no more than 5% of the population. So the sample size lowercase n is no more than, which means less than or equal, 5% of the population uppercase n. Okay. So this is going to be the three requirements that we need to check first before we can actually moving on to the calculation of the confidence interval to estimate the population proportion. So after we check the three requirements, and if they are all good, now we are ready to calculate the confidence interval to estimate the population proportion. Okay. So suppose that a simple random sample subset n, lowercase n, is taken from a population, 1 minus alpha times 100% confidence interval for the population proportion P is given by. So whenever we calculate the confidence interval, we need to know the lower bound. So this is the calculation for the lower, excuse me. So that's the calculation for the lower bound. So the lower bound, we're gonna use in the idea, we're gonna take the point estimate minus the margin of error. So we're gonna take the point estimate. So in order to estimate the population proportion, we're gonna use in the sample proportion as a point estimate. So we're gonna take the sample proportion P has minus, this is the calculation of the margin of error E. So we take z sub alpha over 2 times it by the square root of P hat 1 minus P hat over n. So that's gonna be the calculation for the lower bound. Now for the upper bounds, it's gonna be similar ideas also. So we're gonna use in the point estimate, but now we're gonna plus the margin of error E. So we're gonna take the point estimate P hat plus z sub alpha over 2, the square root of P hat 1 minus P hat over n. So this is gonna be the calculation for the lower bounds and the upper bound. So in this calculation, P has the sample proportion. And the way that we calculate the sample proportion is x over n. So we should be okay with this. And once again, this is the calculation for the standard deviation that we learned from section 8.2, right? So the square root of P has 1 minus P has over n. This is the calculation for the standard deviation. So the only thing that we need to this is the z sub alpha over 2. So what is z sub alpha over 2? Where z sub alpha over 2 is the critical value. So we're going to say this is the critical value. So z sub alpha over 2 is the critical values corresponding to the given confidence level. So how we calculate z sub alpha over 2? What does it mean by this calculation? We will talk about this later. Now let's go back to the calculation of the lower bound. So the lower bound is P hat minus this calculation. The upper bound is equal to P hat plus this calculation, right? So the calculation z sub alpha over 2 times the square root of P hat 1 minus P hat over n, that's going to be the margin of error E. So this is the calculation of the margin of error E. So this is the E is equal, let me put this there. So the margin of error E is equal z sub alpha over 2, the square root of P hat 1 minus P hat over n. So that's the calculation of E. Yeah. So we take the point estimate plus or minus the margin of error E. So z sub alpha over 2 times the square root of P hat 1 minus P hat over n. That's going to be the margin of error E. So after we got the answer for the lower bounds and the upper bound, you might need to interpret the answer, right? So what does it mean by that answer, lower bounds and the upper bounds, in the context of the application? So this is the interpretation. So we're gonna use in this format to interpret the answer for the confidence interval. So you're gonna fill in the percentage right here. So we are 90%, we are 99%, we are 95%. Confident that the population proportion of some variables will lie between the lower bounds right here and the upper bound. So we're going to use in this format to interpret the confidence interval. So we are 99% that the proportion of people who concerned about climate change will be between these numbers and this number. So that's it, the way that we do the interpretation of these confidence interval. Okay, so that's really much the summaries of the calculation and how we interpret these confidence interval, right? Now, the only thing that we haven't talked about is the z sub alpha over 2 is the critical value. So let's give you the definition how we calculate z sub alpha over 2. So z sub alpha over 2 is some calculation that we used it before, but we didn't officially give you this definition. So let's see what is z sub alpha over 2. So before we talk about Z sub alpha over 2, we're going to give you the general definition of Z sub alpha. So what is Z sub alpha then? So the notation Z alpha or Z sub alpha is the Z-score such that the area under the standard normal curve to the right of Z sub alpha is alpha. So that's going to be some Z-score. Okay, so we need to find out some Z-score such that, the area under a standard normal. So this is a standard normal. So you got to remember standard normal, right? So a standard normal, which means that the mean is zeros and the standard deviation equal 1. This is the area to the right is alpha. So the area to the right is alpha. So we did something similar in chapter 7. We find out the Z-score such that the areas to the right under the normal curve, right? So we finding the Z-score given the area. So in order to find out this Z sub alpha, we're gonna use the inverse norm. And then for most of us, in order to keep it consistent for all of us, whenever we're using the inverse norm, you have to show the area to the left and then the mean and the standard deviation. Yeah, so that's how we calculate Z sub alpha over 2. We're using the inverse norm and make sure that you show the area to the left. Yeah. So the Z sub alpha indicate that alpha is the area to the right. But when you're using the inverse norm calculation, you have to rewrite that in terms of the area to the left. So how we're going to find out the area to the left then? So let's give it a try. So we're using the inverse norm, right? But how we're going to rewrite to get the area to the left if we know the area to the right is alpha? So what is the 1 minus area to the right? 0, 1. And what's going to be the area to the right in terms of alpha? So going to be the inverse norm. And then 1 minus alpha. Yeah, so 1 minus alpha. And then 0, 1. So we're going to use an inverse norm, 1 minus alpha, because alpha is the area to the right. Yeah, so alpha is the area to the right. We're looking for the area to the left. We subtract alpha from 1 to get the area to the left, and then using the inverse norm. Yeah, okay. So this is the definition for Z sub alpha. Okay, so this is the general definition for Z sub alpha. Now, after we got the idea of Z sub alpha, we can calculate similar idea for Z sub alpha over 2. Okay, so let's give it a try, everyone. Let's find out what is Z sub 0.13. So Z sub 0.13, so by definition, we have 0.13 in the area to the right. Yeah, so I'm going to say area to the right is 0.13. Now, because we know the area to the right, now we can find out area to the left. So area to the left equal 1 minus the area to the right. So it's going to be 1 minus 0.13, which is 0.87. Okay. So we got that's going to be the area to the left. Now we are ready to find out Z sub alpha, Z sub 0.13. Yeah. So Z sub 0.13, we're going to use the inverse norm. And then we have to show the area to the left, and area to the left equal 0.87. The means of zeros and the standard deviation equal 1. So that's how we calculate Z sub 0.13. So once again, Z sub 0.13, which means that the area to the right is 0.13. So you have to subtract 0.13 from 1 to get the area to the left. And after we got the area to the left, now you can plug into the inverse norm. Yeah. Now we're going to use a calculator to get this answer then. Okay. So we're going to go second verse and then go to the inverse norm calculation. Now the area is going to be 0.87. And then my mean is going to be equal 0. Standard deviation equal 1. And this is going to be the area to the left. Yeah. Okay, so this is going to be 1.1264. 1.1264. Okay. So that's going to be 1.1264. Okay. So that's going to be the critical value such that the area to the right is 0.13. Okay. Okay, let's try one more time, right, everyone? Okay, so let's try one more time. So what is Z 0.98? So Z sub 98, which means that the area to the right is 0.98. So after we know the area to the right is 0.98, we have to find out the area to the left. Okay. So area to the left equal 1 minus area to the right. And then that can be 1 minus 0.98. So that's going to be 0.02. Okay. Now, after we got the area to the left, we are ready to answer this question, Z sub 0.98. Okay. So Z sub 0.98, we're going to use in the inverse norm. And then area to the left is 0.02. And then the means of zeros and the standard deviation of 1. Okay, so that's how we got. Okay, signal. Okay. Now we're going to use a calculator to get this answer then. So second was inverse norms, and then the area 0.02, and then the means of zeros and the standard deviation of 1. And this is the area to the left. Yeah. Okay, so let's see what's the answer. Negative 2.0537. So negative 2.0537. Okay. So that's how we find out Z sub alpha. Okay, so that's the general definition. So Z sub alpha is going to be the critical values of the standard normal distribution such that the area to the right is alpha. Okay. So after we got the ideas of Z sub alpha, now we can apply to the Z sub alpha over 2, because in the calculation of the confidence interval, we have the Z sub alpha over 2. So before we can find out Z sub alpha over 2, we need to know what's the alpha. And then if you want to know alpha, 1 minus alpha is going to be the confidence levels. Yeah, so 1 minus alpha is the confidence level. So alpha is the complement of the confidence levels. Okay. So we're going to summarize the 3 basic critical values. Yeah, so frequently used confidence levels and their critical values. So we're going to try to fill up the table, so we might recycle this answer later on, everyone. Okay. So when they give you that the confidence levels is 90%. So how we're going to find out alpha? So what number minus alpha going to give you 90%? Yeah, so 1 minus what number give you 90%. So we can find out what's the alpha over here. So 1 subtract alpha is equal 90%. So alpha is going to be 10%, right? Yeah. So we can say that's alpha is going to be equal 10%. Okay. That's alpha. Yeah. So alpha equal 10%. So 10% going to be 0.10, right? So I'm just rewrite as a decimal. So alpha is equal 10%, yeah. So 1 minus 10% going to give you 90%. So alpha is equal to 10%. Now, after we know alpha is equal to 10%, now we're going to find out alpha over 2. So it's going to be 0.10 divided by 2. That's going to be 0.05. Okay, so we just got alpha over 2. So alpha over 2 is going to be the area to the right. Now we have to find out the area to the left. So 1 minus 0.05 equals 0.95. Okay. Now we are ready to plug into this calculation, Z sub alpha over 2. Okay. So this is going to be the calculation of Z sub alpha over 2. Yeah. So that's going to be equal Z sub. We just know alpha over 2, right? Alpha over 2 is 0.05. Okay. So we want to find out what's the critical value such that the area to the right is 0.05. So it's equal to inverse norm. And 1 minus, yeah, so 1 minus 0.95. Yeah, so 1 minus alpha over 2, which is calculated already. So that's going to be 0.95 the means of 0, and the standard deviation of 1. Okay. Now let's see what's the answer from your calculator then. Okay. So we're gonna go second was inverse norms. And then the area is gonna be 0.95. The means of zeros and the standard deviation equal 1, and this is gonna be the left tail area. Yeah. Okay, 1.6449, 6449, 1.6449, 1.6449. So you might use the answer with 4 decimal place, or most of the time for the z sub alpha over 2, we usually route it to 2 decimal place. So you might use it 2 decimal place or just using more decimal place to get the answer more accurate. Yeah. So this is how we find out the critical value corresponding with the 90%. So you might recycle this answer for further calculation. So if the question gave you the confidence levels in 90%, then the critical z sub alpha over 2 is 1.6449. Now, similar idea, you can try the next levels of confidence, 95%, right? So if we have 95%, then what's the values of alpha then? So alpha is a 1 minus 95, yeah. So 1 minus what number give you 95? So alpha is gonna be 5%, right? So 5%, which means 0.05. Okay, that's good. Now, after we got alpha, then we're gonna move on to the next calculation, alpha over 2, which is 0.05 divided by 2. That's gonna give you 0.025. So alpha over 2 gonna be the area to the right. Now we're gonna find out the area to the left. So 1 minus 0.025. That's gonna give you 0.975. That's the area to the left. Now, after we got that, we're gonna plug into the inverse norm calculation. So to get the critical values then. This is gonna be 0.025, and this is gonna be 0.975. Now, what's the answer there? Okay, so we're gonna go second was normal inverse norm, not normal CDF, inverse norms. Yeah. The area is 0.975. The means of zeros and the standard deviation of 1. Yeah. And then we're gonna go down to paste. Yeah. Okay. So the answer is gonna be 0.95. Oh, 1.96. Yeah. So 1.96 actually, because it's a 996. So we're gonna route it to 96. Yeah. So 1.96. Yeah. So 1.9600 if you round it to 4 decimal place, or you just got 1.96 here. Okay, so you got the idea, right? Now we're gonna try one more time with the 99% then, okay. So when we have the confidence level, see 99%, then alpha will be 1 minus alpha is equal 99%. So what should be alpha? So alpha is equal 1%, which is 0.01. After we got alpha, we're gonna divide alpha by 2. We do the same procedures. Yeah. So it's equal 0.01 divided by 2, 0.005. Okay. Now, after we got alpha over 2, we're going to do 1 minus alpha over 2, 1 minus 0.005. That's going to be 0.995. And then we are ready to plug into this calculation, the inverse norm, to get the critical value, z sub alpha over 2. Okay. Equal, what is it then? So we go second was inverse norms. And now the area will be, oh, this is 995, sorry, this is 0.995. Yeah, the area to the left is 0.995. I forget to change it, okay. Oh, not that one. 0.995. Okay, and now the means of zeros and the standard deviation equal 1. We have the left tails area. Let's go down to paste. Okay. So 2.5758. So 2.5758. Okay. So this is going to be how we got the critical value based on the 3 common values of the confidence level, 90%, 95%, and 99%. So you might copy these tables on the cheat sheet for the following test, right? And then use it because we calculated in advance already, so you might use it, yeah. So those are the three critical values corresponding with the three common values of the confidence level: 90%, 95%, and 99%. Okay. So we got ready. We okay with this calculation already, right? So now we are ready to plug in to the calculation for the confidence intervals, right? The lower bounds and the upper bounds, okay? You might recycle the answer from the table for the calculation of the confidence intervals then, okay? Okay, so we are ready to try the first question then. Okay, so in March 2018, a survey asking 1,291 registered voters nationwide if they are concerned about climate change. 891 people say yes, they are concerned or very concerned about climate change. Obtains a 95% confident interval. So they were looking for a 95% confident interval for the proportion of what? Of registered voters who are concerned about climate change. So we want to know what's the 95% confident interval to estimate the proportion or the population proportion of registered voters who are concerned about climate change. Okay, so we will see. So we're talking about the 95% confident interval for the population proportion of people who are concerned about climate change. So before we moving on, we need to check the condition, right? So what's gonna be the condition? Okay. Okay. So make sure that you double check the condition before we actually work with the confidence interval, right? Okay. So what's the first condition then? Okay. So the first condition is simple random sample, So make sure that the sample that we select going to be at random. So which means that the 1,291 people that we select going to be at random. So, okay, so that's going to be the first condition. The second condition is n times p hat times 1 minus p hat have to be more than or equal to 10. Okay. And the third condition gonna be the sample size n have to be less than or equal 0.05% of the entire population. Okay. So the first condition, simple random sample. So make sure that the 1,291 people we select gonna be at random. The second condition is this one. Do we know this? Is it true? Okay. So you have to double check this condition, right? So the sample size, do we know the sample size? Yes, we know the sample size, right? So how we know the sample size? So let's summarize the question. The sample size n is equal 1,291, and we have x equal 891, which is the numbers of individuals that have some specific condition, right? And then the confidence level, the question give us is 95%. Okay, so that's how I summarize the question. We know the sample size n now. We know x is 91, so the C level is 95%. So we need to know the p hat, and the p hat equal the sample proportion. So we need to calculate the sample proportion p hat. You guys remember how we calculate the sample proportion p hat, right? So p hat is equal x over n. Okay, so x equal 891 divided by 1291. 0.6902. We did that calculation earlier, right? So you can remember the first example we did earlier, which is calculate this. Yeah, so 891 divided by 1291, 0.6902. I just recycle that answer. Okay. So that's going to be the estimate the sample proportion p hat. Now we are ready to plug in to double check the condition, the second condition. The sample size n 1,291. The sample proportion 0.6902. 1 minus 0.6902. You want to make sure that this more than or equal to 10. Okay. Let's see if it's true. Okay, 1,200 or 200 up 291 times it by 0.6902 times it by parenthesis 1 minus 0.6902. Okay, we got 276, 0467, so it's going to be 276. Okay, so 276, 0467, 0467, which is more than or equal to 10. So this condition is true. Okay, yeah. So the second condition is okay. Now I'm gonna do the okay. So now I'm gonna do the third condition, right? So the third condition, which means that the sample size have to be less than or equal 5% of the population. Okay, so the sample size is 1,291. Make sure that's going to be less than 5% of the entire population. So we have the entire population, everyone in the US right here, right? So we only select 1,291. So actually it's going to be less than 5% of the population. Yeah, so that should be okay. So the third condition should be okay, right? Now, after we check the condition, everything good, then we can move on and do the calculation for the confidence interval then. Okay, let's keep going, right? So after we check the condition, now let's move on, calculate the confidence interval then. Excuse me. Okay, so let's take a look at the formulas, everyone. Okay, let's see if we are ready for the calculation. So we got the sample proportion p hat, but we don't know the z sub alpha over 2, so you might need to calculate the z sub alpha over 2, or you can use in the table that we just completed right here, right? So using the table that we have earlier, we can find out the critical value. So based on this question, the confidence levels is 95%. 95%, yeah. Okay. So the confidence levels is 95% using the previous table. Yeah. So using the previous tables of critical value. Okay. We have, okay. So using the previous tables of critical value that we have the 95%. It's going to be 1.69. Okay, so I just copy this then. Okay. So based on the 95%, we have the critical values are going to be 1.69. Okay. So we got everything ready. Now we're ready to calculate the lower bound. Okay, so let me copy the formula for the lower bound. Okay. So the formula for the lower bound, that's we have this one. Okay. Now I'm gonna substitute the formula then. So what's the p hat? So p hat we have 0.6902 minus z sub alpha over 2, 1.9600 times it by the square root of a quotient. Okay. On the numerator, we have p hat again 0.6902, 1 minus 0.6902 divided by the sample size n, which is 1,291. Okay. So this is going to be the calculation for the lower bound. Okay. So you might give it a try, everyone. Let's plug it into the formula or plug in this calculation onto your calculator to see what's the answer then for the lower bound. Okay, let's give it a try then. So 0.6902 minus 1.96 times it by the square root of 0.6902 1 minus 0.6902 divided by 1291. Okay. Hit the enter key. Okay. So the answer for the lower bound will be 0.6650. If I round it to 4 decimal place, 0.6650. Okay. So 0.6650, that's the answer for the lower bound. Are we good? Now, similar ideas, I'm going to just copy this calculation and we modified it to get the answer for the upper bound. So the only thing different between the lower bounds and the upper bound calculation is the point estimate plus the point estimate plus. Okay, so that's really much is the difference. Yeah, so we're going to take the point estimate plus the margin of error E. Okay. So this is the shortcuts, everyone. You might go back to the previous calculation and hit the enter key to copy that, right? And you're gonna use the direction key, move it to the subtraction right here before the 1.96 and change in that subtraction by just hit the enter key. And that's gonna be easier. You don't have to input everything again, okay? Now hit the enter key, so it's gonna be 0.7154, 0.7154, okay? So we just got the answer for the lower bounds and the upper bound using the given formula. Okay. So I hope everything goes right. So you can try this calculation again on your calculator to see if you got the same answer then. Okay. Now, after we got the answer for the lower bounds and the upper bound, now we need to wrap up this question by using the interpretation then. So I'm going to say we are 95% confident. Yeah. That the what? Yeah. That the proportion of registered voters nationwide who are concerned about climate change. Yeah. So I will just copy that phrase. Yeah. So that the proportion of registered voters nationwide who are concerned about climate change will lie between the lower bound is 0.6650 and the upper bound is 0.7154. So that's going to be the wrap up of this calculation. Yeah. So you might take a look up on the work that we completed so far, everyone. So based on the given information, you might summarize the question and check the condition using the confidence level to find the critical values, right? And after you got the critical value, you using the formula to calculate the lower bounds, using the formula to calculate the upper bounds, and then just put the interpretation to wrap up the question. Okay. So this is the procedure. That's how we do the confidence intervals and how you interpret the final answer of the confidence interval. Okay, so you might you might pause the recording for a few seconds and take a look up this works again, right? And then review that again until you feel more comfortable. Okay. So this is how you work out the confidence interval by hand, right? So using the formula step by step, that's how we work out the question using the formula. Luckily, that we do have a shortcut that you might use it to get the answer. So let me show you the shortcut answer right here. We actually have a shortcut on the calculator that you might use it to got the answer then. Okay, so this is gonna be the shortcut that you might use it, everyone. Okay. So let's take a look at the shortcut that you might use it so we can get the answer easier. Yeah, where I am. What is it? Okay, give me 1 second. What's happened with my file? So let me open this again. Yeah. Okay. Okay, so this is the answer that we got right here, everyone. I don't know what did it do. It's got cut off, right? Okay. Now we're gonna talk about the shortcut that we might use it to get the answer then. Okay, so this is gonna be the shortcut that we might use it to get the answer. Okay. So this is gonna be the shortcut we use it right here, everyone. So using the shortcut to get the answer for the confidence interval. So let me copy this then. Okay. So this is gonna be the shortcut that we might use it to get the answer for the confidence interval. So you're gonna go to the start keys and then go to the test option and then use an option A, one proportion, Z intervals. Okay, so let's take a look at your calculators, everyone. So we're gonna go start and we're gonna go to the middle option, use the direction key to move it to the middle option. And you're gonna keep going down until you see, oh, we're gonna go to the test, okay. And then you're gonna keep going down until you see option A, one proportion, Z intervals, okay. So after you select the one proportion Z interval, you just input the X value. So based on the summary that I have right here, the X value is 891. And then the sample size N is 1,291. And the C level is 95%. So you can put the C level in terms of the percent, or you might put the decimal. This should be fine. Yeah, so one or the other. Yeah, so you can put in terms of the decimals or percent. And then after that, we're going to go down to the calculate. Okay, there we go. Yeah, so this is going to be the answer that we have earlier. Now we can compare with the answer from your calculator. So 0.6650. Okay, so this answer is more accurate because we just chop off with 4 decimal place. So that's why there is a difference, right? So we have just a rounding error. Yeah, but it's very close. 0.6649, 0.6650. And then for the upper bound, we have 0.7154, 71,539. So you can round it to 54. So that's good. So this is going to be the answer for the lower bounds and the upper bound using the calculator. Okay. So you might use the shortcuts, everyone, to get the answer for the confidence interval to estimate the population proportion. Yeah, okay. Okay, let me copy one more example so we can try it together. Then I will just copy this. Okay. Okay. So we're gonna try together with this example right here, everyone. Example number 4. So for those of you who enjoy working with the shortcut, right, you might use a shortcut to get the answer. That totally work. Yeah. So this is how I'm gonna show you how to show your work if you're gonna use a shortcut to get the answer then. Okay. Okay, so we're gonna take a look at example number 4 and we're gonna try with the shortcut then. Okay. So in the surveys again, 1,291 registered voters nationwide. So we survey the same amounts of people. And we find out that 749 of them were in favor of the death penalty for people convicted of murders. Now the question asking us to find out the 90% confidence interval for what? For the proportion. Proportion of what? The proportion of registered voters nationwide who are concerned about climate change or who are concerned about death penalty for the person convicted of murder. Okay, so that's the characteristic we focus on the if they are in favor for the death penalty for person convicted of murder. So that's gonna be the characteristic. So you might summarize the question, right? So what's gonna be the sample size there? So the sample size N will be 1291. So what's the values of X then? So X equal 749. Then the confidence levels is 90%, right? Okay, so that's the summarize of the question. Okay, now after we summarize the question, then before you can use a calculator to get the final answer, you need to double check the condition, right? Okay, so what's gonna be the condition that you need to check then? Okay. So I'm gonna copy the 3 conditions as we have earlier to make the process quicker, right? So this is gonna be the 3 conditions that we have to check, everyone. Okay. So the first condition, make sure that we have a simple random sample. The second condition, make sure that you're gonna get the sample size n times the sample proportion p hat 1 minus p hat more than or equal to 10. Now, can we check this condition? Okay, so before we can check this condition, you might need to calculate p hat. Okay. So p hat equal x over n. Okay. So x equals 749 divided by 1291. So let's see what's the answer of this then, using the calculator. So 749 divided by 1291. Okay. So 5802, 5802, 0.5802. Okay. So after we know the sample proportion p hat, we can plug into the second condition to double check. The sample size 1291 times it by the sample proportion 0.5802 times it by 1 minus 0.5802. Have to make sure that this is more than or equal to 10. Okay. So is it true? We will check it then. Okay, so gonna be 1291 times it by 0.5802 times it by 1 minus 0.5802. Okay. So that's going to be 314.4462. 314.4462, which is more than or equal to 10. So this condition is true. Okay. So the second condition is good. And then the third condition, you want to make sure that the sample size is less than 5% of the entire population. So we have this a 1,291 register voter compared with how many people that we have, how many voter that we have nationally, right? So nationwide, then I think that should be less than 5%. Okay, so that's gonna be good. So this is the first step. You need to check the condition. Now, for those of you who want to use the shortcut, then this is the work that you might need to show. You need to give me the name of the shortcut. So using one prop z interval. Okay, so you're gonna show me the name of the function that you use it, one proportion z interval. And after you show the name of the function, you have to show me the input that you use it. So x equals 749 and n equal 1291. And the confidence level, you might use it in terms of percent or decimal. So it's going to be 90% or going to be 0.9. One or the other should work. Yeah. So you need to mention the name of the shortcut that you use it. And after that, you have to show me the input that you use it. And then just run the calculators and get the answer from your calculator then. So we're going to go start and we're going to go to the test option. And then you're going to go down to option A. One proportion z intervals. Yeah. Hit the enter key to select that option. Now the x value is 749 and n is equal to 1291. And then the confidence level, you might use in a decimal or percent. That should be fine. You can use it 90 or you can change it to 0.9. Yeah, so 0.90 is also work. Yeah, so in terms of an integer or in terms of a decimal. Yeah. Okay, so now we're going to quote the answer from the calculator. So the lower bound is 0.55758. Okay, so we just quote the answer from the calculator, 0.55758. Okay, so 758, comma, the upper bound will be 0.60276. Yeah, so 0.60276. Okay, so this is gonna be the work that you might need to show to convince me how you got the answer then. So this is easier because we're just using the shortcut, right? But make sure that you know the name of the shortcut to use it to get the answer. So after we got the answer, we need to wrap up this question with the interpretation, right? So we are 90% confident that the what? The proportion of registered voters nationwide who are in favor of the death penalty for person convicted of murder. I'm gonna just copy that then. See. Will lie between The lower bound 0.5576. I will wrap the answer with 4 decimal place. And the upper bound 0.6028. Okay. So this is how we wrap up the question with this interpretation. Okay. So that's going to be the option. You might use it also. You might use it as shortcut, totally fine. So for the last two example, the first question, which is using a formula to get the calculation for the lower bounds and the upper bound, right? And then the second question, which is using a shortcut directly to get the answer. So this is the work that I expected you might need to show on the test. Yeah, so you need to show the name of the shortcut and what is the input that you use it for the calculation. And after that, you just quote the answer from the calculators and then interpret the answer in the context of the application. Yeah. So I hope with the two examples to give you how we calculate the confidence interval, you feel comfortable with this calculation of the confidence interval, right? Okay. So we actually have one more question, which is example number 5. Okay. So that's going to be the extra practice question. You might give it a try on your own, everyone. Give it a try. You might use the formula to get the answers, or you might use a shortcut to get the answer. That's good. Okay. So one or the other. Yeah. So you might use the formulas or the shortcut, one proportion z interval to do the calculation for the confidence interval. So I'm going to stop the recording at this point for you to do some more practice question on this section 9.1. I will see you next time for the next recording then.